Yeah, it started already.
No, it's not visible.
I'll have to go to that thing. Yeah, it's not showing me the option.
Yeah, we are live now. Hari,
Yep.
yeah, we can start with the
Hi
first.
everyone. Good morning. Thanks for joining on a Saturday weekend. It's a fantastic morning. Hope you're able to see my desktop.
Yes, yes, it's visible. You can run in presentation mode. Yeah,
Yep.
wonderful.
Yeah, in a minute we'll start.
Yes.
Yeah, hope all of people can see screen, or they can also raise thumbs up or something. They can see the screen.
Yeah, yeah, it's visible.
Okay.
Is it visible to all the participants? Kindly show thumbs. Yeah, wonderful.
Okay.
Thank you. Thank you.
So let me know when you can get started. I'm ready to go.
You can start, Hari.
Okay, yeah, welcome you all. Thank you for being in the morning. It's 10 a.m. Indian Standard Time. This is Hari on behalf of Springbok Technologies. Welcome you on board to the Campus to Corporate VLSI webinar series. This is the second of the pre-webinars. This is the 12th of September. And there are 12 different topics covering all the aspects of VLSI design. So there are two pre-webinars and 10 webinars. And there are 12 distinguished speakers from different leading companies. There are elite speakers, the senior managers and leaders of the industry, who's who in the chip design industry around the globe, not just from India, from abroad and everywhere. They're coming and addressing all the students throughout India, right? And this is me, Harish Seshadri, and we are part of the organization team. We have Karthik Anand from Speka Works in India Private Limited. And we have my colleague Madhubala Manjuri. She is not in the call today. She's from Springbok Technologies. We have Swaroop from GTGP. Hi, Swaroop.
Hello.
And from IEEE, we have a couple of people. They'll join us on the next webinar. Mr. Srikant Chandrasekharan, he's a senior director at IEEE. Mr. Pratik Saxena is a sales manager at IEEE. I'm from NGO partners, Mr. Muralidharan, founder and managing trustee of Sevalaya. I'm Mr. Prasanna Parthasarthi, vice president donor relations of Sevalaya. So this is the organizing team. And this we have the second webinar today, career opportunities in VLSI. Mr. Harish Bharatwaj from Broadcom is the director of product marketing. He's going to present on and we have a few important things on 15th of September, that is Tuesday, 5:30 p.m. India time. We have a trends and opportunities in VLSI from Sriram Sarakopan, Vice President NXP Semiconductors in Austin. Then we have a fourth webinar on 18th of September. Niyaz Mohammed, Chief Architect of Radisys, one of the leading companies on 5G technologies, is going to talk about the FPGA design for a wireless communication. He's going to be talking that on 18th September, right? And rest of the thing you have them all in the emails. I'll not talk about it. We have people from Qualcomm, we have people from ARM India Private Limited, and we have people from Altran, and we have people from Semiconnect India Technologies, and we have from people from Invecas, and we have one of the leader coming from Intel, and we have people coming from one of the CTO from Saintra is going to address us. And finally, last session is about one of the keynote speakers about he's executive chairman of Alpha IC Incorporated, right? So this is the kind of agenda for the next 1 month, and I'll let Harish share his presentation with that. I want to introduce Harish. Yeah, Harish is going to talk about the career opportunities in VLSI, and he graduated from University of Madras in the year 1991, and he did a master's in University of Massachusetts after that, and he has about 28 years of experience in the industry, and last 10 years he's with with Broadcom Incorporated. He's a director of product marketing. He takes care of the North America market and the Southeast Asia market for the custom chips, the ASICs and custom chip solutions. That he's doing that particular market. And prior to that, prior to Broadcom, he was with LSI Incorporated, with Hewlett Packard, and with Cadence. And with this thing, I let Harish take over the stage. Thank you, Harish.
Thank you, Hari. First off, I want to thank Hari and the Springbok Technologies team and the Sevalia Foundation for their noble venture in trying to inspire young students into a good, successful professional career. And also, thanks for giving me this opportunity to talk to you all. Good morning. As Hari introduced, I work for Broadcom Inc. Broadcom develops not just semiconductors and systems and softwares solutions for wireless, wired networking, as well as storage and industrial markets. Specifically, Broadcom in the semiconductor space, Broadcom develops silicon semiconductor for switches and routers, cable modems that you use in your houses, wireless antenna devices, embedded processors, storage controllers. So Broadcom participates in a wide variety of market. We have offices in multiple countries. In India, we have an office in Bangalore. We have an office in Singapore, in China, and USA. I am based off California. Today, I will mainly cover two topics. First, I will give you an overview of what semiconductor industry is, and then talk about what are some of the career opportunities in the semiconductor industry and what kind of skill sets are required to have a successful career in this industry. Before I go to the actual presentation, I have these two kind of pop quiz. The first one is to see, do you know what semiconductor industry means? So you have to respond with an yes or no. And if the answer to your first question is yes, then the second question is, does a career in semiconductor industry sound exciting to you? Would you like to work in a semiconductor industry?
So, dear
I'll wait for
participants,
Swaroop.
Harish. Dear participants, please answer the first question. Do you know what semiconductor industry means? Kindly go for it. Yes or no? Do you know what semiconductor industry means? I request all the participants to share their views. Do you know what semiconductor industry means? Everybody participate, share your opinion. Nothing wrong about it if you don't know. We are here to discuss and explore
Yeah.
this world. Yes.
Yeah, if the answer to your first question is no, that means you don't know what semiconductor industry means, then you cannot be excited about working in that industry.
Harish,
So,
the poll response says 82% say yes, 18% say no. So should we go to next question?
sure.
Yeah. So the next question is for those 82% people. Does a career in semiconductor industry excites you, or is it exciting to you? Kindly answer this question. Does a career in semiconductor industry sounds exciting to you? Please go for it. I request all to share your views. Go for it. We'll take 10 seconds more. But answer this question. Yes. Yes. Go for it. Okay. Great. So Harish, 92% of the people are saying that yes, semiconductor industry sounds exciting to them.
Okay. Mathematically, it shouldn't be correct because 88% said, right, 12% did not know what semiconductor industry is. So you cannot be excited about an industry you don't know about. But it's okay. Thank you for participating. It's just to get your interest level. This is not to test your knowledge. This is just to see what your interest is. Now we'll go to the presentation. Before we go into the industry overview, I want to just level set with some basic definitions. What is a semiconductor material? Semiconductor material, by the name, because of the name semi, means they are neither a conductor nor an insulator. Example, like silicon, the electrical conductivity of the material is in between that of a conductor and an insulator in its pure form. Now, why is it important? The important aspect or property of the semiconductor material is that by proper control of impurities, the electrical conductivity of this material can be controlled. You can control whether to make it conduct or not conduct, and that is the critical value of this material, right? And one basic control function is to basically switch on or off the flow of electricity, and voila, you got the transistor function, right? So semiconductors, also called as integrated circuits, ICs, or microchips, or chips for short, are basically electronic components that are made out of a number of these transistors. If you look at a modern day electronic device, if you take an electronic device within your cell phone or your laptop, almost all of them these days would have at least million of these transistors. Because you are trying to put so many of them into one small device, the name came the very large scale integrated circuits, VLSI, right? That's where the name comes from. And semiconductor industry is basically the collection of all the companies that's involved in the design and manufacture of these semiconductor components or ICs. With that definition, let's go see what a semiconductor markets and what kind of products it is. You would know most of these. Some of the common semiconductor components that you use are the consumer electronics, be it a laptop or a tablet or a cell phone or a smart watch or even a pacemaker that goes into your heart. They have electronic components. Next comes kind of like the communication devices. Like you take your cell phone that talks to the cell phone tower that you see on the sides of the streets. Those towers have electronic components. You work in a corporation or in a university or a campus, and all of those connections go to this, a campus switch. So these are all like communication devices that are electronic components in them. And then compute, whether it is a big server that's within your company, in university, or in a cloud, or supercomputers, there are electronic components in them. Then there are automotive, right? There are the electronic within a car is actually increasing. Self-driving cars is a big market that's coming up. So there are a lot more electronic components that goes into a car these days. And then in the industrial, be it medical systems or test and measurement systems, there are a lot of electronic components. So, and then there are military devices. So in general, we are talking about electronic components that goes into all of these markets. On the right here shows of all the electronic components that are built, what is the percentage split of electronics for each of these market? How much of electronics are built for communications space? How much for the computer on the server space? Industrial, consumer, automotive, and then the government/military space. As you can see, the communication space and the compute space are two largest market share or space for semiconductor devices. Now, we want to understand how big is the semiconductor industry or the market. There are a lot of ways to measure a market. One way to measure is how much company that's participating in this space make revenue wise. So if you take the year 2019, all the semiconductor companies together made around 410 US dollars billions. This is 410 billion US dollars together in the year 2019. And this number in this year 2020, it is expected to become around approximately $450 billion. That means from 2019 to 2020, the industry is growing more than 10%. And we all know we are in this pandemic, COVID-19 pandemic situation. Even in this climate, the semiconductor industry is really growing. That means there is opportunity is there for all of you there. Now, what is driving the growth in the semiconductor market? A lot of things. I'll just highlight a few of them. Technology scaling, meaning some of you may have heard the famous Moore's law. Moore's law, simplistic, in a very simplistic way, says can a transistor, a basic device, be scaled smaller and smaller in a very cost effective way? Some people claim this Moore's law is dead, but reality is that's not the case. It's still going strong, and today we are developing semiconductor devices, circuits, which are using 5 nanometer transistors. And in couple of years, we are looking to be looking at developing devices that are like 3 nanometer. So the device continue to shrink and continues to be cost effective, and that's driving the growth. And 5G radio technology is something I'm sure you're all heard of. What it provides, the benefit, a higher bandwidth and a very low latency. As a consumer, you will say you have your cell phone, connected to a 5G network, you get data faster. From a business point of view, it enables a lot of other applications like factory automation or safety, self-driving cars, telesurgery that is becoming a very critical application now. So these are applications that are driven by the 5G technology that needs more and more semiconductor manufacturing. Machine learning or artificial intelligence is another very key technology driver, which is trying to have our computers have a cognitive computing, as in think like our human brain. And you have devices like voice recognition devices that you use today, including your cell phone. Video surveillance basically is facial recognition, or other smart social media services that is enabled by this machine learning. All of these technology basically means that there is more and more demand for semiconductor components, right? So you could see the revenue chart in year 2000. The semiconductor industry, together, the value was around $200 billion. In 20 years, it has more than doubled. So that's why we are saying, okay, it is a growing market and there is a lot of opportunities there. Now, before we go into what kind of jobs, let's look at within the semiconductor industry, there are different companies playing different roles. Mainly, we would look at 3 different categories. First, companies that are involved in doing design. That is, they are designing the semiconductor or the VLSI device, integrated circuit. Some of the example companies are like my own company, Broadcom. You would have heard Qualcomm, Texas Instruments. These are companies that are primarily involved in design of ICs. And then there are companies that develop tools, software tools, to help with the design, test, and manufacture of these ICs. Example companies include Cadence, Synopsys, Mentor Graphics, which is now bought by Siemens. And then there are companies that actually produce or manufacture or fabricate these devices. Intel, Samsung, TSMC are 3 main companies that manufacture or fabricate these devices. There are some companies that do more than one thing, as in not just design, not just tools or manufacture. For example, Intel, as you know, it not only manufactures devices, it also builds microprocessors that goes into your laptops and servers. So does Samsung. And Synopsys and Cadence not only develop tools, they also do some design work of building blocks that goes into these chips. In general, if you have an engineering major in computer science, communications, electrical, or electronics, you can develop a career in the semiconductor industry. Whether you want to be a design engineer, whether you want to be in a tool development engineer, or whether you want to participate in the manufacturing process, the skill sets and the specialization needed would vary. Over the next few slides, we will discuss what kind of skill set, what kind of job description is in each of these. First, we'll talk about design engineer. All right. It typically, so in the right hand side here is kind of, if you break open your cell phone and spit out all the components that's there inside, this is kind of what you would see. Starting from the antenna that receives the radio signal to the analog components that basically doing power amplifying and filtering off with these signals. You have what are called as analog to digital conversion, because the external signal that comes in are analog signals. It gets converted into digital signals and gets processed by the DSP and the CPU within the cell phone, and be it display or the data goes back, that is converted from digital to analog and goes back to the antenna. At a high level, you can combine all these components into three categories. Analog components, as I said, could be this antennas, power amplifiers. These are dealing with pure analog signals. Digital components like the CPU or the DSP engines, they are dealing with digital signals. And then mixed signal components that deal with the combination of analog and digital signals. Based on this, you could be an analog design engineer, a digital design engineer, or a mixed signal design engineer. Whatever be the career you like, whether analog or digital, mixed signal, whatever it is, the key thing that's needed for a design engineer is to know whatever that you're designing, what does that mean, right? What is that component do? If I take analog to digital converter as this particular block here, what does it do? Understanding that function is the most important thing before you can become a successful engineer. Right. Now we'll go one step further and now discuss, say, if you want to be an analog design engineer, what does a typical analog design engineer do? On the right hand side here gives a kind of the flow for analog. If you are trying to design an analog design block, say a filter, you specify the filter at a higher level. HDL stands for higher level description language. So you specify the filter requirements at a higher level. You do an architectural level simulation, if you're familiar with tools like MATLAB, to say, okay, does that specification meet what you want, right? Basically. Then you take the specification and do a circuit design, right? In the analog world, call it, like, say, circuit design, schematic design. A schematic would look like this, a combination of devices. Once you define the schematic, you're going to do a circuit simulation, say a SPICE simulation, to see the circuit meets the specification. Next step is to take the circuit and kind of map it into polygons, basically your layout. This layout is what actually is sent to a manufacturing unit to manufacture. But once you have the layout, you have to do what is called as parasitic extraction, because once you place the layout, you have to know, okay, how far they are spaced. There are wires connecting it. The wires have delays. So you have to analyze that the layout, not only this circuit, this layout actually meets the target function that you are designing, right? A circuit, that means an analog design engineer, right, is doing multiple things, right? You could be designing the schematic, you could be doing the layout, you could be running simulations, you could be doing all of them. So just a design engineer does not mean all you're doing is laying out the schematic, right? You could be doing a combination of these steps that's needed to get the whole work done. With respect to analog design, the key thing to note is you are dealing with device or transistor level behavior. That means some of the coursework that you need to focus on that'll give you are like circuit analysis, basic RLC kind of network circuit analysis, signals and systems, semiconductor devices. That's where you deal with all these BJTs, all kinds of transistors and device and circuit design. So having these kind of coursework, would help you appreciate what an analog design engineer goes through and kind of help you prepare for it. Okay. Next, we go a digital design engineer. Actually, so as a slightly different, because you are now dealing with digital signals. In this case, majority of the technology you're dealing with binary signals. That means you're dealing with ones and zeros. A typical digital design block that you may get is to go design a state machine, and a state machine, as you would have seen in your logic design coursework, will look like what is the state and the arches to the state and what conditions the state transition happens. You use again another high level HDL language, be it a Verilog or a VHDL, to specify the state machine. And then a tool, an automatic tool, basically takes that description and maps it onto gates and flops, and then goes to the next step. Now there is a layout tool which takes this gates and flops and creates this layout. While you go through this process, just like in analog design, you have to verify that whatever your design is correct. So you use simulation tools, verification tools to make sure it's working or the design is correct. Unlike analog design, the digital design is done at a slightly higher level. You're not optimizing at the transistor level, and hence it's a little bit more standardized and more automated tool flows. A design engineer could be doing Verilog description of state machines or different logic circuits, and some other design engineer is taking this description and using the tool to map them into gates and flops, and some other engineer is taking that and using a layout tool to create the layout, and somebody else could be doing the verification. In the digital design engineer world, there are a lot more tools to automate the process as compared to an analog design engineer in a very generic way. And some of the recommended coursework for a digital design experience is computer architecture and logic design, microprocessors, and microprocessor-based system design is another course. So these are good courses that you may want to focus to get a feel for what a digital design engineer function is. Next, we'll talk about, as I said, tools, right? These are tools that are helping a design engineer to design or to verify or to manufacture and test these semiconductor components or ICs. So this basically, the tools are written in either programming languages, right? That means these are kind of software development jobs, but software development jobs that understands the semiconductor design flows and stuff that makes you a better EDA tool development engineer. Most of the EDA tool development problems are what I would call as optimization or minimization problems. For example, in the digital design flow in the previous slide I showed, it's taking a Verilog or a VHDL description to map it onto logic gates and stuff. In your logic design course, you may have done this Karnaugh maps or Quinn McCluskey or different kind of Boolean optimization um, exercises. So a synthesis tool is basically doing that in an automated way. So whatever you learn on those things are very in those classes are very, very useful. And if I another thing is the place and route tool. We talked about the layout tool. All it's again trying to do. So I have found the logic uh, structures, and we know how they need to talk to each other. Now you are going to physically place them, and you connect them in as small an area as possible, so that you're minimizing the wires connecting them. That means you're minimizing the parasitics, and hence you get a better performance. Net, this is an optimization problem, and hence, a good uh, background on graph theory, or C++ programming, or other Python, or this different programming skills is very critical to be a successful EDA tool development engineer. Now, the last part of it is actually manufacturing and test. On the right here, I have a little flow chart. We talked about design, whether it is an analog or a digital design. We said we go through the design. Eventually, you get a layout, which is a bunch of polygons that gets transferred to the manufacturing company, as we discussed, whether it is Intel or TSMC or Samsung, and they take that database, which is called as GDS, and they produce the eventual product, right? So they create what is called as a mask. From the mask to the wafer to the die and the packaged device, and then you finally test the device and ship to the customer. So a semiconductor manufacturing, involves like a clean room here, and testing equipments to test before we ship to the end customer. The manufacturing, as you would see here, requires a variety of engineering, not just engineering, different disciplines to come together. Device physics, like strong background in semiconductors to understand transistors at as we discussed 5 nanometer 3 nanometer kind of that kind of size, how the device behaves. Chemistry, as we talked about semiconductor materials and adding pure semiconductor and then impurities, and so what kind of materials gets added to get the right conductivity you want. And then of course electrical, electronics, or mechanical engineering needed in terms of getting these not only the equipments and actually going through the whole process of manufacturing. Majority of the semiconductor jobs, or for the manufacturing jobs, are very usually close to where the manufacturing facility is. This is unlike, let's say, as I said, if we take a company like Broadcom, who I work for, we have design engineers in US, design engineers in China, design engineers in India. So the design engineers everywhere because you're doing the design job. But when it comes to manufacturing jobs, you are more tied to the location of the manufacturing facility or the facility where the testing of the product happens. 3 major manufacturing facilities are in Taiwan, called the TSMC, are in Korea, which is the Samsung, and in USA, which is the Intel. So a manufacturing or a test engineer locations or jobs are probably not as common as a design engineering or a tool development engineering function. Okay. In summary, I want to make sure you understand the semiconductor industry is very strong and it is continuing to grow at a very good pace. All that means is there are a lot of career opportunities for you both in India and outside India to form a very successful semiconductor career in this industry. As we discuss some of the courseworks that I mentioned, have very direct connection to the job function you would do in a company, in an industry. So these courseworks are very, very relevant. So you should uh, figure out which coursework excites you and interests you, and correspondingly choose a career within the industry. And beyond coursework, one thing that I would strongly recommend is do it yourself experiments. Like if you are really interested as to be an analog engineer, you could go say, I from building your own radio transceiver with components, like discrete components. Or if you want to just build a system or a digital system and see how it works, you could go create a music lighting system, right? Play a music and see the lights controlled with that. So stuff like that, doing such experiments, do it yourself experiments will give you a better feel for whatever you learn from the coursework. With that, I I don't know if I am on time.
Yeah, you are 10 minutes ahead, 10, 15 minutes ahead of time, Harish.
Oh, okay. I didn't realize that. Okay.
Yeah. So yeah, I would like to thank the audience. Yeah, maybe you can do the poll. Yeah, let's do this poll. Yeah.
Yeah.
Swarup?
So
Yeah,
Swarup will.
sure, sure, Harish. Dear students, dear participants, we'd like you to answer one question now. That do you know what semiconductor industry means after this amazing discussion? Now, are you aware of semiconductor industry? Kindly answer. Do you now know what semiconductor industry means? So yes, Harish, 100% people agree with this now that they are aware of semiconductor industry. That's
Fantastic.
phenomenal. Now let's take the next question. Yes, that does a career in semiconductor industry sounds exciting to you? So what's your say now? Do you think that if you get a job in semiconductor industry or you want to carve a niche in semiconductor industry, does it sound interesting to you or exciting to you? Wow, 100% yes.
2% no.
So this has been one of the best sessions,
4%
probably.
they said no. Yeah. 3%.
Yeah,
Okay.
3%.
That's good.
That's good. Yeah, 3, 4, 5% are
That's
saying
good.
no. That's good. We should have such people
Okay.
also.
That's good.
Okay.
Yeah,
That's good. Thank you for the honest feedback. That's what you
Yep.
need. Yeah.
So
right.
yeah, Harish, if you can stop your presentation, I want to share the thank you slides what I have, and then we can go to Q&A.
Okay. 1 second.
Let's spend more time on the Q&A. We have time. So people, please stop posting your questions.
Request all the participants to post your question in the question section so that we can take them up.
Okay. So let
Okay.
me go in detail about the webinar 5. I think we just skipped on the webinar 5, which is on 29th of September. We have Sundara Balaji, who's the director of Qualcomm. He's going to talk about low power design, right? We all know low power design is extremely important, the topic of the day, right? So he's going to have a fantastic, I reviewed the slides, so it's a fantastic presentation. So make sure that you attend all the webinars, right? And on webinar number 6 is on 1st of October. So on SOC verification methodology from Palaniappan Somasundaram. He's a director from ARM India Private Limited. Yeah, right. So it's a very interesting topic again, because verification is the important thing. Unless you verify, you won't know it works, right? So how do you get your product right first time in the market? So that's the theme. So he's going to talk about that. All right. And on 5th of October at 6 p.m. India time, we're going to have a DFT methodologist for SOC design. Anand Venkatachalam is from Altran Coimbatore. So he's going to talk about DFT methodologies. What is the design for test? How can you do the structural verification? So he's going to talk about that. How can you increase the fault coverage? So he's going to talk about all those things. On 7th of October, we have Sudhir Reddy from Semiconnect Tech India Private Limited. He's going to talk about the physical design challenges. What are the various challenges related to the layout, clock tree design, physical designs, the routing, physical verification. So he's going to talk about that. What are the technology challenges? What are the design challenges? We're going to talk about that at 6 p.m. on 7th of October. And the last four sessions on 9th of October, 6 p.m. India time again, is Srikanth Neelam. He's from Indicas, Hyderabad. So he's going to talk about FPE system design. What is important of prototype? How we can prototype your design quickly before you make that design into the chip. So he's going to talk about all those things. And then on 12th of October, Shankar Narayanan Bhatt, from the director from Intel India Private Limited from Bangalore. He's going to talk about the silicon qualification and post-silicon testing, how we can take your design to production, how can you how we can test your silicon post silicon after get your silicon from the fab, how can you qualify that, how can you take it to testing to production. So he's going to talk extensively on that. And then we have very interesting sections on 11th and 12th webinar series, that's on 14th and 15th October, both on 6 p.m. IST. Uday Joshi, who's a chief technology officer of Sientra India Private Limited, is going to talk about the product development cycle and what does it take to develop a product, right? How can you take your design ideas into product, right? You may want to become an entrepreneur, you may have fantastic ideas, right? You have a Make in India campaign and you have a Swadeshi processor challenge going on, right? You want to make that as a product. What does it take? For those of you not aware about Swadeshi, processor challenge, please join our Telegram group. We keep sending emails. Swarup, can you post the Telegram link in the chat session so people can join the Telegram link? We'll keep discussing about such things in the about that in our Telegram group. So please join.
Hari, yeah, should we share the feedback link?
Yeah, please share the feedback link and the Telegram group link also.
Sure. So dear participants, just a second. Dear participants, I'm sharing the feedback form link. I request you all to complete this feedback, and once this session is done, this link will be closed. So we request you to share your feedback. This is the link that I've shared in the live chat section. You can just click on that link and share your feedback. Hari,
so the feedback form is important. We all need to know like how we did. There are always room for improvement. We can do better. So please do give us a feedback for all the speakers or for the Springbok also, right? And so we get participation certificates only if you attend all the webinars. You fill the feedback form. There are some quizzes. You have to answer them. Then only you get the certificates. IEEE certificates and Springbok certificates, you'll get it at the end of all the webinars. So it's important to give the feedback forms and answer the questions. Then you get a certificate at the end of after October 15th, within a week's time, you'll get the certificates. And the last webinar is about another keynote session. We have one keynote on the webinar 3, the 15th of September, that being Engineers Day. Sridham Surakom is going to talk about what are the various challenges on the trends and opportunities in VLSI. On the last session, we have another keynote session by Pradeep Vajram, who is executive chairman. He is from United States of America on the East Coast, from a company called Alpha ISIS Corporation. He's a very successful entrepreneur, and he's going to talk about my entrepreneurship journey. So he's going to talk about that, right? So that being all the 12 webinars, and so we want to sincerely thank all our donors, sponsors, and partners. Getting to Goal Professional is one organization represented by Swaroop, and so we thank them profusely for being a partner. And Sri Venkateshwara College of Engineering, there are one of the donor partners there. They have donated to the NGO. So we sincerely thank the SPC management for being a donor partner for this webinar series, and AirMeet for giving a wonderful platform to us. And Mohit from AirMeet is in this webinar. So Mohit, thank you so much for the AirMeet and your organization for that. And one of our partners in training, SEER Academy, they're enabling electronics and enterprises. They are in the training industry for very long. They are successful training partners. We work closely with them. We thank Hirdesh of the SEER Academy being such a part of this particular webinar series. And Indian Institute of Information Technology, Design and Manufacturing, Kanchipuram, IIIT Kanchipuram, IIIT DM Kanchipuram, rather it's called. We thank the Dean and Director of the particular institute for being agreed to be a sponsor and partner for this webinar event. And the last two partners are Chennai Institute of Technology, Transforming Lives. It's called CIT. They're in Chennai. So we thank to the chairman of Chennai Institute of Technology for donating to the NGO cause. So we are extremely thankful to Mr. Sriram Parsar, the chairman of Chennai Institute of Technology. And we also will thank to the Mentor Card, the next gen mentorship platform. So one of the webinars will share more details about that. We want to help the student community how to acquire your skills beyond the webinar, how we can stay in touch with us, right? So we thank Mr. Ashish of Mentor Card being a partner for this webinar series. So over to the questions.
So, Hari, we'll just take questions, and at the end, we'll do vote of
Yeah,
thanks, right?
exactly. Yeah. So
Okay.
we have
So,
10
could
minutes.
you please?
I'll go one by one. I'll go
Yeah,
one by
yeah.
one.
Please
Yeah,
go through the
yeah.
question section. Dear students, we have shared the feedback form link in the live chat section as well as the Telegram link in the live chat section. Request you to go through both the links, and now we'll be continuing with the question answer
Okay.
session.
Yeah,
Hari, please
one
take on.
second. Yeah.
Yeah.
So, as a beginner and fresher on the low tier college, how can I explore and get good placement in VLSI company? He's from Tarak. He's from Gayatri Vidya Parishad College of Engineering.
Um, I don't think you should worry about whether you're in a low tier college or a high tier college. At the end of the day, it is how much you know about the coursework you've learned and what is your interest level and how well you do these interviews is what's going to get you the job and the career. So first of all, you should remove your the notion of am I in a low tier or high tier, the number one college in the country or the world. So please just focus on the coursework and do your best to understand what it means and get help these days. um, if there are a lot of times I'll tell you I've gone online on YouTube's on courses that I have done 20 years ago I had forgotten, but there is amazing sources of lectures available. You could learn from professors across the world in India, all over the world. Those lectures are available free. So the information, the data is available. So you shouldn't be worried about what college you are. Um, that doesn't restrict your opportunity.
Thank you, Harish. Swarup, can you make the question answered? Being a host, I don't have the permission. Yeah, question number one, we just discussed it. Make it answered. Swarup? Okay, next question from
Yeah, yeah, I'll do
next
it.
one
I'll
from
do it.
Radhika. Right? For an MTech student, if they don't get internship, what can they do to get a job in semiconductor company? So that because every company demand experiences people.
Okay, so if you are not, you're talking about, okay, I'm not getting an internship, I
Hmm.
have completed. The best thing I would suggest is try to do uh, this kind of do it yourself kind of tools and exercises. For example, I don't know whether your experience, your interest is in analog design or digital design. For example, if you go to Texas Instruments as a company, it's a very good analog products company. They have made so many of their tools and infrastructure available that you could do some design experiments and create your own, you know, kind of small products
Yes, right.
and demonstrate. So that's how I would suggest you create a differentiation. At the end of the day, you have to be just one step ahead of your competition or somebody else that's looking for the job, right? So these activity I would suggest would help you.
Okay, thank you. Swarup, we can make it answered. Yeah, so question from Senthil. We have 13 more minutes to go. So it's question from Senthil. In general, if someone is having a degree from VLSI design and some 2 years experience in VLSI front-end verification, share platform or links to update skills to get into the domains of healthcare, automobile, and wireless communication.
Okay, I didn't understand the
So what
question.
does
So
it mean?
I understand there's 2 years
Yeah,
experience.
what are the
Yeah.
platform or links to get the skills of the healthcare, automobile, and wireless communication? Domain experience. How can you get the domain experience? That's a question.
Okay. Um, it's either you do reading by yourself, or you have to do some kind of coursework that
Right.
specializes in that domain. I'm glad you are thinking about domain expertise because when you are able to think tops down, okay, this is a product, what it does, and then underneath this product, these are the components that is going to go in and how I can help design those components. I think
Right.
it is a good thought process to think that way, I would suggest specialized courses or reading material. Once you fundamental design concepts remain the same irrespective of the market. Lot of, like, as I said, a digital design engineer for a wireless market space or a healthcare industrial market space will have lot of similarities,
Right.
but having that market understanding will give you the advantage.
Okay, the next question from Nika Gupta from Synopsis. What are the real silicon challenges faced by the engineers where they move from one technology to other technology, for example, from 5 nanometer to 3 nanometer, and how the challenges are taken care? Interesting question.
Okay, I mean, that challenge, that answer alone, you can, that question alone, we can talk for
Yeah.
hours. Um, if you see, actually, if design engineers look to companies like Synopsys to solve these problems in a way, right, to make tools that handle. But there are a lot of challenges, without a doubt. As you rightly said, you go from 5 nanometer to 3 nanometer. One simple thing I would tell you is the design rules. In order to design a layout in a 5 nanometer, if you had 100 rules, that becomes, like 5 times more rules to meet all this to have a good layout. So just the complexity of the rules, and because the EDA tools and stuff is design is an optimization problem, optimizing all those variables gives the tools runtime, the results, quality of the results. So the challenges are numerous. Um, it's hard to just say pick one and say how do you solve it. But fortunately, I would say, companies like, Synopsys and Cadence, and including the foundries that deliver the design kits, or what we call as the physical design kits for these technologies, actually make it happen so that the design engineers can do their job.
Okay, the next question. Uh,
Hari, just before that next question, I want to like request all the participants to share their feedback in the feedback link, and also the Telegram link is shared in the chat section. Kindly share your feedback.
yeah,
Yeah, Hari,
yeah,
please.
from Harbaksh Gupta. Right, sir, how do we study computer architecture? What should we focus more on?
Uh, how do we study computer architecture as in outside of coursework? Because I'll tell you, that's a subject, that's the main coursework that actually got myself introduced, or say excited about doing this design work and stuff. So if that excites you, you read. uh, I what it's hard to say, are you, if you're a current student, you take more coursework with related to computer architecture. And again, as I said, I'll go online, there are a lot of materials available for computer architecture and logic design, and of uh, you got to take advantage of those materials. If you're a student, I would advise take courses like computer architecture,
Hmm.
microprocessors, not just computer architecture, microprocessors, those kind of coursework to get more knowledge
Okay,
on
thank
those.
you. Yeah, next question.
Hari, I wanted to
Can
ask
you
one
continue?
question.
Please, the students first.
Yeah,
Yeah,
sure.
question from Maga. Right, as an electronics engineer, in which area we to grow our knowledge that helps us in the future and have more scope?
As we discussed, you have to pick if you want a job, as we discussed in the semiconductor industry. We talked about whether you want to be a design engineer, what is that you want to be. That was the purpose of this webinar. Hopefully you, during this webinar, or you go watch this again and you get an idea on what each job function is, and see if there is one that interests you. Then you pick that interest and focus more on that, right? So there are a lot of opportunities. As with the main objective of today's webinar is to show that semiconductor industry is big, it's
Right.
growing, there are a lot of opportunities. So it's up to you to kind of figure out where your interest is.
The next question, what do you mean the technology node? What do you mean by 3 nanometer or 5 nanometer?
Okay. So when we are talking about transistor, the way the technology is measured is how small is the basic device is. So when we are talking about 5 nanometer, you are talking about a 5 nanometer being the length of the transistor channel. So the smaller the device, that means the smaller the entire integrated circuit and hopefully cheaper. So the whole objective of technology scaling is as it becomes smaller and smaller, hopefully cheaper and cheaper, and hence the market grows.
Okay, next.
That's what
Yeah,
you're talking about, the size of the device.
yeah, it's distance between the drain and the source of the transistor. If you know what is a CMOS, that's the answer in specific. Okay, question from Siddharth. He has completed MSc from University of Melbourne in electronics. He has done a lot of semiconductor fabrications and names kind of courses, and he lacks industry
Hmm.
experience. How do you get industry experience? Second question is, there's a manufacturing market exists in USA. How does he crack job in semiconductor industry and USA?
Um, I would say job of all the jobs that we discussed today, getting a job in the manufacturing part of the semiconductor industry is probably the most, I would say, the challenging one, mainly because there are not that many companies um, doing manufacturing. So it is definitely challenging. Manufacturing does exist in US. Intel is one of them. IBM is one of them. There are small, but definitely exists. The way to get into that, you should have a very good, like a device physics, kind of like a process engineering background to get into the manufacturing sector.
Question from Paramji Balaji, IIT Goa. If I get a job in VLSI field, can I get an opportunity to pursue my PhD in collaboration with industry and institute?
Uh, PhD, is that correct, right? That's what
Yeah,
I heard.
PhD
PhD?
research. Yeah, yeah.
Okay. Yeah. So I'll tell you, most uh, universities prefer PhDs to be on campus, right? You could have industry collaboration for your project work or some research collaboration you're doing, but majority of the universities actually prefer um, students to be on campus. But there are some um, university professors have started semiconductor companies as from being a professor, right? So that is definitely possible in terms of collaboration. But if you are thinking working as a full time and then getting a PhD, it's not a very realistic goal.
Yeah, the last question. Yeah, so what are the suggestions for a person who wants to work or to do research in the field of communication, either for testing or design?
Can you
Yeah,
repeat the
what
question?
are the
What kind of
suggestions who wants to do a work or research in the field of communication, either in the design or testing? So what do you recommend them?
communications is a very, it's a topic that I really like. It's extremely valuable um, in terms of having a career in the semiconductor industry. The In terms of recommendation, if I would say, if you have a choice or a chance to do higher studies, whether you are a BTech student today or not, I'm not sure. But if you have an opportunity, I would strongly recommend pursuing a higher studies, whether you want to do a master's or a PhD. Particularly since you said you have research interest, I would strongly recommend going the academic route first.
Okay. So I'm an MTech student. I have chosen RTL design and verification as my domain. I do read the required coursework for the same, but as companies demand experienced candidates, how can I tackle this barrier? I think we answered the question, do it yourself kind of thing, right? We spoke. I'll
Yep.
skip it. I'll skip it. All right. And the last question, are there any industries suggested to do research in the field of VLSI for communication?
Yes. If you as we discussed, a lot of the companies, right? If you take 5G radio, why is it so famous, right? Eventually, communications industry is really big. There are a lot of companies interested in communications engineers. The opportunities are plenty for communications.
Okay, well, probably the last question coming up. Somebody from VIT Vellore. Which online websites we can refer for VLSI industries, jobs and opportunities, and also for websites for VLSI industries, news and trending research?
Jobs, there are a lot of, honestly, every country, every domain, every geography changes. So I don't have a very strong, I don't know which job sites are very popular in India. But in terms of news, uh, uh, E Times is one thing I follow. They're very good daily news suggest and then weekly. They have a lot of webinars as well, and so my favorite is actually E Times.
Okay, yeah, Swarup, over to you. You can ask one last question and do thank.
Sure. Yeah, he has already answered that question. I won't repeat that
Okay,
question
yeah,
again.
then yeah, let's thank the.
So, we at Campus to Corporate VLSI webinar series, Springbok Technologies, IEEE VLP, and Sevalaya, we are extremely thankful to Mr. Hari Bharatwaj for taking out his valuable time. And it has been a wonderful session, sir. I must appreciate your whole sneak peek on everything. In very nutshell and in very precise way, you have highlighted the semiconductor industry, the core opportunities, job opportunities, and this has been a wonderful session. This has actually set a tone for our coming webinars. And I believe that everybody who has attended today's webinar would love to attend webinars hereafter because they have understood now the way we are putting forth the aspects. So thanks a lot, Mr. Harish Bharadwaj.
Thank
Thank you.
you. Yeah, we
Thank you,
end the
Swarup.
lecture here. Yeah, thank you so much. Thank you, everyone.
Yeah.
Thank
Dear
you.
students,
Thank
do share
you.
your feedback.
Good luck.
Yeah.
Thank
Yeah.
you. Swarup, can end the meeting. Swarup, you can end it.
Yeah. I'm doing it. Doing it. Just a second, Hari.
Hello?
Hi, Hari. Whether
Hi.
where Hari
Yeah.
Harish
Hari.
left.
Yeah, he probably he left.
Okay, no worries. It was amazing. It was really
Okay,
amazing.
yeah. So we have to request for recording, chat, logs, and everything actually, right? Polls.
Just a second. Whether we are live.
Yeah, let's end it, man. Yeah, I'm out. I'm getting busy actually here.